Hello, and welcome to the webinar, Regulatory Compliance Application Development Considerations for the Next Normal. My name is Eric Wallace with Argyle, and it's great to have everyone joining us here today. I have a few administrative details to share with you, and then we'll dig into our discussion. First, we would like to thank Oracle for their partnership with today's event. They've been wonderful thought leadership partners to Argyle and are committed to providing you with valuable content and a great overall experience. Thank you again to Oracle. We appreciate your joining us here today. We welcome you to stay connected during today's event. For those of you who are active tweeters, please follow us on Twitter at Argyle Exec Forum. I'd also like to take a moment to touch on our content neutrality policy, which we've curated based on feedback we've received over the years from our members. Argyle is very proud and protective of this policy, as it reflects our commitment to ensure the neutrality and overall value of the content presented at our events. We've worked closely with our speaking faculty to ensure that you receive a set of balanced and neutral viewpoints during the session today, and we appreciate our members' support of this policy. Finally, and most importantly, please submit all questions that come up during today's event into the chat section of the interface. Following the panel discussion, we've set aside time for our speakers to weigh in on these questions. Before we start our discussion, I'd like to ask our presenter to introduce himself.
Hi, I'm Donald Smith. I run Java SE product management for Oracle.
Take it away, Donald.
All right, great. So what I want to talk about today is regulatory compliance application development considerations for the next normal. And so just a little bit about me. So I already mentioned Donald Smith, run Java SE product management for Oracle, but you should know a little bit about my history so you know where my biases are, and that you can factor that into the stuff that I'm about to share, some of my experiences, some of the things I believe in. I've been in enterprise software for going on 30 years. I started off as a small talk programmer, which of course means I have a lot of exposure to the financial services industry. I going on those 30 years, I've seen lots of takes on regulatory compliance and watched organizations try to manage keeping up with the pace of technology change, and trying to make sure that all of their environments met all of the standards and obligations that they were required to do, not only legally, but also just because it was a good business practice to do so. So started off as a small talk programmer. I got involved in the Java ecosystem from day one. So I've been in the Java ecosystem for over 25 years now. And that's mostly what I'm going to talk about. I'm going to talk about the experiences and the evolution of Java over the last 25 years, how that applies to enterprise software, some things we learned that I think will be helpful to you on managing your environments for regulatory compliance. So if we've learned anything over the last year and a half, it's that change is the only constant. And we have seen organizations over the last 18 months go through a decade of change in a very short period of time because we were forced to do so. Some organizations did very well because they were prepared for change. They had an environment and systems in place that allowed them to adapt very quickly. And some organizations were not able to do so as effectively. And so I think it's kind of interesting to look at some of the things I'm about to talk about through that lens. So some key takeaways. Basically what I want to do is summarize what I'm going to talk about right now, and just kind of give you the themes and the key points that I'm going to hit on, so that you can keep these in mind throughout as I'm sharing anecdotes and experience and making suggestions. So as I mentioned, the Java platform has gone through many changes in the last 25 years. It started out very much as an embedded development platform targeting set-top boxes, and is now the #1 development platform in the enterprise, right? It's gone through many changes to get there. It's gone through many evolutions from being an embedded platform to a client platform to a server platform, now a cloud platform, right? Lots of things had to happen. We had to be prepared for those changes in order to evolve over time. And a lot of the things we have done to do that are very analogous to what you need to do to be prepared to meet your regulatory compliance obligations. Another point or theme that I would like to make is that, in my experience, there are experts in regulatory compliance, and I would assume many folks listening here are in that camp. But once you get outside of that world of people who are experts in doing that and achieving that for organizations, what you will find is a lot of hand waving that, oh, regulatory compliance just means keeping up with security. As long as we're keeping up with security, we're compliant. But for those who this is their day-to-day and their key skill, we know there's a lot more to it. We know it's about keeping up with stability. We know it's keeping up with performance, but also being able to adapt quickly when environments change outside of your control, as we've seen over the last year and a bit. Another theme is predicting the future is really hard. And I've already said the word flexibility a few times, and I apologize. Sometimes I catch myself saying it too much, but it is key. It's the #1 key of this presentation, is that in order to meet your obligations, the best way to do that is to be as flexible as possible. And how do you become as flexible as possible? It's making sure your development methodologies are as flexible as possible. And then a final theme is just thinking about evolution versus revolution. So we very much think about the Java platform in terms of evolution, introducing change slowly over long periods of time. But there are definitely periods where we need to go through revolutions, where something is happening in the environment, a new technology niche comes along, a new way of doing things, a new piece of hardware, a new operating system, and we need to be able to quickly go through the revolution and then get back into that longer term evolutionary thinking. So those are the points I want to make and the key takeaways of this presentation. So let me, again, I'm going to weave through the first half, the history of Java and how we've thought about change and the reasons we had to think about change. And then I'm going to get into the exact things we did, and then hopefully you'll be able to take that and apply it to your own environments, or at least think about what we did versus what you are doing, and if there's things you could be doing. So again, Java is 25 years old. It had a great start back in the late 90s, and the goals were lofty. So very early on, Java again started off as an embedded platform language, but very quickly it became clear, hey, this is a great platform. Object-oriented programming was becoming popular, but a lot of the Java language and Java platform structures made it very attractive for enterprise development. There was a lot of different vendors involved at that time in the Java ecosystem. So you had options. You could get your Java from Sun, you could get your Java from IBM, you could get your Java from HP, and so on. So that kind of flexibility gave it a lot of headlines like this. Is this the perfect development platform? in the very early days of the Java platform, the financial services industry was heavily involved and involved in the specification body behind the Java platform, in the Java community process. And these are organizations that, of course, are front and center when you think about organizations that have to think about regulatory compliance. And so, my argument would be that from a very early on part of its life, Java has had to think about regulatory compliance because the organizations participating in it required it. So, Java had a lightning bolt start. Those first 10 years, the growth was tremendous, and for some of the reasons I had mentioned already, it was a great platform from a development point of view. The type safety of the language meant that enterprise applications were more robust than alternatives that had existed. And the large number of vendors collaborating was also very key. Now, of course, we had detractors. And of course, for the last 15 to 20 years, we've had lots of predictions that the death of Java was imminent. And luckily, none of those ever became true. And so the question is, well, why is that? Why is it that in 2007, it was believed that Java had stagnated, was finished, and it was going to become the next COBOL, when in fact it's become the #1 programming language in the cloud, right? What are the things that happened? There were periods, of course, where things did lag. Near the end of Sun Microsystem, so going into 2008, 2009, progress was slow as Sun struggled a bit with the business model overall. But eventually, Oracle, of course, bought Sun, took over Java. It took a year or two for Oracle to find the right gears and get Java rebooted. So we did see that period. And in those early days, there were struggles, right? So there were hiccups along the way where, there's some technical debt, especially on the desktop, had built up in the final days of Sun and then in the early days of Oracle. And we had to make, rapid strategic changes to how we were developing and deploying the Java platform. Okay, so these are important lessons that we learned along that time frame that I can now share with you some of the things we did and how we've managed to avoid these issues since. Right. So basically, the faster the world moves, the more challenging it becomes to maintain compliance obligations. So what did we do? So the first thing we realized is that before you can move faster, you have to be able to stay in place. And what that means is, if you go back into that time frame, so I'm going to focus for a few years around the end of Sun and the early days of Oracle, as Oracle was figuring out exactly what the state of the Java platform was and what we needed to do to drive it forward again, move Java forward. Is it was being pulled in a lot of different directions, right? So it was being pulled into a lot of different architectures. It was being pulled into a lot of different niches, and the way it was being built had become incredibly complex, right? There was different platforms of Java targeting mobile devices. There was different platforms of Java targeting enterprise applications, different editions of Java targeting what we now call Java Card, which is the little pin chips you have on credit cards. That's Java Card based platform. So it was being pulled in a lot of different directions, and what was key was standardizing and centralizing all those different perspectives and bits into a core that could allow us to build and deploy faster. And so basically, we needed to centralize, get ourselves into a single place for all the different pieces. And then because it was so hard, we had to find ways to do it more often so that we would be able to adapt and evolve as we needed to going forward. And we had to do all these things while keeping developers happy, which is extremely challenging, of course, but keeping the C-levels happy, the CSO happy, meaning addressing those security concerns, and delighting our customers. So what did that mean? So there's 5 key things that we did to kind of get us through that transition and set us up for the next decade and hopefully for the next decade to come. So the first thing is selecting the source code management. So as I alluded to earlier, one of the challenges that we had was that our source code management was spread over different systems and tools. And so it became really important for us to standardize and centralize how we managed our source code. Now, if you're listening to this as a modern application developer and maybe not from an enterprise, you may already be, using the kind of the current state of the art on GitHub or other similar modern source code management tools. But when you hear about this, you need to put yourself into the perspective of 25 years ago, the project started. And 10 or 15 years ago is when things needed to go through its first major change. And so, for us, that meant moving from a lot of these really legacy systems to a system called Mercurial, for those of you that may be familiar with that. But that move, when it was done, we had to consider, well, what if we need to make another change in the future? Because at that point, that was the state of the art. And we expected that in the next decade, things would evolve further. And sure enough, they did. And so we are now running everything on GitHub, right? So most of the development of the Java platform is done in the open on GitHub. And of course, we have some closed source bits for the security updates and so on. But in general, getting that source code management environment right was a significant undertaking. It took a lot of time, a lot of evolution, but it was absolutely critical. So that would be the first thing I would ask. If you're looking at your enterprise and are you able to meet your regulatory compliance obligations, I would ask, well, what is your source code management? That's very much the root. And if you find yourself in a hodgepodge, if you find yourself with a bunch of legacy tools being used, that would be one of the first things I would recommend that you would look at modernizing. Quickly following that is I would ask, well, how is it you're managing your dependencies? And so, and what I mean by that is most modern applications have a large set of dependencies, often open source. But even, if you have a 15, 20-year-old system that you're working on, you probably have a number of commercially licensed dependencies that you're obligated to. Or you may have internal dependencies. So you may have different parts of your organization that are providing binaries and libraries to you that you have to manage. And so much like the source code management tool, you need to ask yourself how you're managing those dependencies. How are you tracking those? How are you keeping up to date when those dependencies change? How are you able to monitor and track security issues within those dependencies? And again, if you are currently writing modern applications, You may be using modern dependency management tools, and this may be kind of second nature to you. But if you're an enterprise and you're dealing with some legacy applications that you just want to keep running in production, you may have some legacy tools. You may have scripts. You may have Excel files that are managing your dependencies, believe it or not. So that would be the next thing that I would suggest that organizations look at when trying to make sure that they're able to keep up with their regulatory compliance obligations. The third piece is about your environment. And what I mean here is it's similar to dependencies, but a little different, because we're talking here more about the hardware and the operating system. So you could argue hardware is a dependency and an operating system is a dependency. But when I talk about dependencies, as I just did, I really mean they're more libraries and APIs and so on. Whereas with the environment, it's more about the hardware, the network, the disk, the operating system, and all the pieces that go around that. And from the Java perspective, one of the challenges we had was the incredibly diverse environments that we had to run in, right? So, the 10-year-old Windows machines needed to be able to run Java on the latest state-of-the-art Windows machine, while also supporting Linux, while also supporting Spark, while also supporting whatever the latest Apple hardware of the day happened to be. Meanwhile, underlying underlying hardware components like disk storage were going through their own changes, where I/O was getting faster at a faster degree of change than CPU performance, and so there were certain things at certain points of application development where the ability to read and write to disk was improving faster than the processors, which led to certain design considerations for pushing more stuff in and out. And so the question was, does your environment support that? And is your application able to take advantage of those things? Right. So that would be the third thing that I would recommend that organizations look at carefully is, in terms of hardware and operating system, not only processors, but things like disk storage, network, and so on, what is your ability to control that? And what is your ability to adapt to that over time? And how are you going to manage that? So for us, it meant simplifying. So we did our best to simplify and work with partners on the niches, right? So we made sure that we focused on the core markets. So we looked after the 80, the Windows, Mac, Linux, and then relied on partners who had niche hardware, niche operating systems, niche network capabilities, and had them work on those capabilities. All right, so the fourth piece is look at your automated pipeline. So again, at the risk of repeating myself, if you are a modern application developer and you have robust continuous integration and continuous deployment environments driving your development, then you're very fortunate, right? Because in a lot of enterprises, that's still not a thing, except for maybe the newest and latest and greatest applications and projects that are happening. There's a lot of development and a lot of organizations that are still working with legacy waterfall type models, and the notion of automation is scripting, right? And so our advice, of course, would be to automate as much as your pipeline as possible. Make sure those builds are happening so that you can detect changes and issues as soon as possible, but also that you have tools and frameworks to help you with deployment especially if you have a 24/7 constantly updated type application, which would be normal for most modern web apps. And then the fifth thing that we would recommend people look at is your release trains. So Java historically, the way we did releases was a major release every 3 years or so. Sometimes it was a little less, sometimes it would be a little longer, but the goal would be to have a major release every 3 years or so, have a year overlap with the next release, and then end of life. So the model was always that there would never be more than two versions at a time. There would never be any more than 2 versions at a time, and you would have sufficient time to migrate between those versions. Okay, now, practically speaking, it didn't really work that way, and there's a couple reasons for that. So number one is there was always pressure to maintain the older releases for longer. So organizations would get an enterprise application up and running, stable, deployed, high value, and organizations just did not want to touch it. It works. We don't need to extend it. We don't need to modify it. We just wanted to keep working. And so there was a hesitancy to move up to the next release because you have something working and you just don't want to have to touch it. And so the goal of having no more than 2 versions at any single time quickly evaporated because there was a lot of customer pressure to keep versions around for much longer periods of time. Right, so that's the first challenge. The second challenge was that the 2 years or 3 years between releases often slipped into 4 years and 5 years. And the reason for that is we would want to bring a new feature that would be essential to developers in modern application development. We would want to bring that to production quality as a GA release. But it would take a few months longer than we had expected. And so we would push the release out and then push the release out until eventually it would go in. And then even then it wouldn't be as stable as we would like. And it would take a few months of releases and patches in order for it to get as stable as it should be for production use. So not only did we have the challenge of organizations and customers wanting versions to live a lot longer, but we also had the pressure of trying to get as much as possible into a release because the time between releases was so long. So for those and other reasons, we completely changed our release model, and frankly, we stole the model from the Mozilla Foundation and how they started to release Firefox. And it worked well for them, and it has worked extremely well for us. So what we did was we changed the model that we would have a developer feature release of Java every 6 months. And we would put into that release whatever was ready. And it had to be production quality ready. And if it wasn't, we didn't put it into the release, right? And we would do that every 6 months. But we know that enterprises don't want to have to pull in a 6-month update if they have an application in production. They just want to stay on that older release. So we introduced the notion of long-term support releases, and then gave people a choice. So you can either get on the 6-month release cadence and always have the latest, greatest, still very high quality, always production quality, or if you have something in production and simply don't want to have to change and keep up, you can do that as well by staying on long-term support releases. This model worked really well for us, and we've noticed that a lot of other organizations are following suit. In not only the software tools and platforms space, But even in the enterprise, we see more and more enterprise offerings now where even you as a consumer can choose between staying on I'm going to use the word stable, but what I mean by stable is not changing, not that it's going to crash a lot. You have the option of staying on a stable web platform or going on a quickly evolving web platform, knowing that you may, as a consumer, have to get comfortable with moving widgets or slightly different behavior and so on in the use of that application. So this notion of multiple release trains is finding its way into enterprise development as well. There's a lot of very popular mobile applications that push versions to consumers that are quickly changing as an option, right? So it's something you might want to consider, and one of the benefits of that is it now gives you different options on how you're managing all of those other things to meet your regulatory compliance obligations, right? It's, if you need to, you can always push from one to the other. You can push the long-term support into the rapidly moving train if you needed to, or vice versa. So you have some extra flexibility on how you're delivering things. You also have different expectations built up by the users of the software. So you may be able to get some benefits there as well. Okay, so those are the 5 key things that we have gone through as part of that transition 10 years ago, as I mentioned, and those changes have put us on a really solid footing going into the next decade, and modern application development, especially for the cloud. So the key here is that these things take time, right? So we talk about the refactoring of the code base, and as I mentioned, we went through one major refactoring from some really old stuff to stuff now that we would think of as old, but at the time was state of the art. And then later went through another transition to more modern cloud code base refactoring with GitHub. And managing our dependencies, managing our environment and the different hardware and operating system platforms that we support, and underlying hardware components, and then changing the way we think of release cadence has helped us, but also gives our customers a lot more flexibility in terms of how they use our platform. All right, and so as I have mentioned, the results have been positive. There were definitely moments of pain, and I shared with you earlier, some of the coverage of those moments of pain. But there's been a growing perception for the last several years of Java as, not some COBOL-like language that is in stasis, but it is a fast-moving platform that is constantly thinking about the needs of modern application development and everything that modern application development means, from how developers think about it, to the hardware, to the types of applications being developed. So this is just a quick summary. Source code management, reproducible pipeline, your dependencies, your environment, your pipeline, and the key here is that you need to make sure that the components you're using and the dependencies you have can evolve with you. And can go through the kinds of evolution and revolutions that you need to over time. And the bottom line here is that flexibility is key, right? And in everything that I just walked through is really about building flexibility into your development environment, and that should position you better for meeting your regulatory compliance obligations, right? What I didn't really hit a lot on as I went through this, as it was implied, but let me kind of hit on it a little bit more directly now, is as you go through those changes, obviously the dependencies you have need to be able to adapt and evolve with you. And if they can't, like if you're stuck with some piece of legacy code that you're no longer able to update, you need to make sure that you have the frameworks around that can isolate you from that unchangeable thing with wrappers and APIs or platforms around it that can adapt with that change. And while that may be challenging at the operating system level or the hardware level, there are still things you can do. And this is where a product like a Java SE subscription can really help, because we offer you support on all of the legacy versions of Java. So if you happen to have inherited a library that's still running Java 5, which is long EOL, odds are we'll be able to help you run that. And we'll be able to help you run that in an environment that is stable, performant, and secure, because we have experience in wrapping those things, providing more modern APIs over the top, and letting you carry on with your modernization activities. So having flexibility in your supply chain and working with vendors that have the platforms that can give you that flexibility are key. All right. I know listening to webinars is challenging, and I really wish we could be live in a conference somewhere and I could offer to chat with folks over a beer afterwards. But here we are. And so if anybody does want to follow up afterwards, feel free to shoot me a message on Twitter at DonaldOJDK. Feel free to DM if your question feels like it might be sensitive. And I believe we can open it up to any questions that may have come in.
Great. Thank you, Donald, for that insightful presentation. Like you said, we're going to open up for Q&A and encourage attendees to submit questions using the chat feature, which is on the right-hand side of your screen. So we'll just jump right in and address some of the questions that have come in from the audience during the discussion. The first question is, we struggle with persuading our DevOps and IT DevOps and security ops teams to talk to each other. Do you have any advice for that?
So it's a good organizational theory question. And often, a lot of politics involved there, no doubt. So in my experience, the challenge there, it depends on the size of the organization. Meaning, is it a 1,000 developer organization, or is it a 50,000 developer organization? And then the management style of that organization. So is it hierarchical, or is it more matrixed, right? So those types of things matter. So just keep that in mind as I'm answering. But generally, what I have noticed is that the reason there's usually challenges there is competing goals, right? So the CSO is trying to keep everything secure, period. Doesn't matter what it costs. Obviously it matters what it costs, but the goal is to keep things as secure as possible given the resources available. Whereas, developers may be trying to push hard into the latest technology niche, not because it's cool and they want to do the cool, fun thing, but because the developers believe it's the fastest way to get something done, and will provide, a platform, an application platform that will be stable, performant, and able to write applications quickly for the foreseeable future. So that in and of itself is a way to reduce costs going forward. Whereas, the procurement team and the CFO might be looking at cash flow of CapEx versus OpEx, right? And so this is why, working with vendors that can provide you the most flexibility in your development platform is key, right? So that the CSO is saying, we need to be able to make sure everything we're running is known to be secure, that there's not published SEC alerts on versions of software that we're running. That is our goal. But you may have a development organization that says, we have this Java 6 version in production, and it will be really expensive for us to have to do any changes to it. Why can't we just let this old insecure version run? And that's why, if you're working with the right vendors, they can hopefully provide you that platform that provides you that latest security baseline that gives you the best of both worlds. It allows you to be stable and secure without having to go through the effort of modernizing and rewriting to the latest releases if that's not something that you need to do. But meanwhile, having the vendor for the greenfield applications or those applications that are due for a modernization, giving you the latest performance, stability, and feature capabilities that you can take advantage of in the latest releases, so that you're best set when you go forward from there. So so it's really all about thinking about the different goals and perspectives of the different groups that are in the conflict, and then trying to find solutions that can address all of those needs.
Great, thank you. The second question is a security-related question, and that is, what's the biggest mistake you've seen companies make in trying to change user behavior, and how did they solve that?
Change user behavior. Interesting. So I'll have to kind of fall back in time a little bit and then see if I can think of something that might be more modern and relevant. But one of the challenges that I experienced going again 7 to 10 years ago was the interplay between the operating system, the browser vendor, and then the platform provider on top of that. So imagine you had Windows running Firefox with Flash, or you had a Mac running Safari and Silverlight, right? So and then, of course, Java would fit in there on the client, but also on the back end, or and when I say as the client, I mean literally in the browser as an applet, or as a rich client desktop application, right? So the challenge that we saw was everybody feels responsible for the security of the user in that environment. Which they should. But what it would mean is the operating system would say, hey, are you sure you want to run this? And then the browser would say, no, really, are you sure you want to run this? And then us as a platform provider would also say, no, really, are you really sure you want to run this? And it's not that we were worried. It's just that we were all unsure exactly what the other vendors were going to do. And so that meant collaborating. And it meant working with Mozilla and meant working with Microsoft, not only the Windows team, but the Internet Explorer team, and Apple, and so on. And so we did those things so that we could come to a common agreement on how those things would interplay and work together. And though, some of those things took time, but we were able to get to a pretty good place there. And even now, like funny enough, it was just a few weeks ago, Mozilla Firefox still launches Java Web Start applications. It's a kind of desktop application through the browser. And we've been collaborating on how they detect and launch those files, giving users a good experience. So I'm not sure I answered that in the best way, but I guess the bottom line there is, you want to work with vendors and technology providers that have the ability to partner with companies like Microsoft and Apple and Mozilla at the same time, to improve those experiences, which at times for various reasons can get pretty ugly. But when you have an enterprise or a lot of individual users, going through pain because of it, you want to be working and using technology from organizations that can collaborate and do those things, as we have done.
Great, thank you. I thought that was a great answer to that question. So then,
thank you.
Last and final question is if you were starting a software development process from the ground up, what would you do to integrate performance, stability, and security from the very beginning?
Yeah. Well, yeah. I guess time is flying here, isn't it? So, I guess what I would do is, like, I would go to those five things that I had talked about through the presentation. So greenfield, the first question, of course, is, well, what kind of application is it? Is it targeting consumers? Is it targeting enterprises? Or is it a headless application? Is it some sort of data processing system? Because I think the answer will vary slightly depending on what kind of application it is. But first and foremost, you're going to want to make sure you're using a modern source code management tool. You want to make sure you're using a modern dependency tracker. You're going to want to make sure all of your libraries and dependencies, like the Java platform, it's a dependency. You want to make sure those are being, that you're getting them from a vendor that is going to be very capable at keeping up and driving the change and making fixes as quickly as possible when and if you uncover challenges, but that you also know is going to be there in 10 years and 20 years when you're successful with this application, right? So you're going to want to choose those vendors very carefully. You're going to want to choose your environment very carefully, and follow a lot of the same questions that you might have around the dependencies, the libraries, and platform itself. And then you're going to want to make sure you get a good release cadence. And I can't say enough how great it's been having 2 release trains, one long-term support release cycle, and then a shorter-term release train, and then having those both available and allowing your customers, regardless of whether it's a consumer or an enterprise or what kind of application it is, allowing your users to decide what makes the most sense for them. That gives you a lot of flexibility. It gives you a lot of flexibility on how you're releasing things, and how you adapt to things over time. And I guess kind of the bottom line there is plan for success. Like, assume you're going to be successful, and that those choices and decisions you're making early on, that somebody's going to have to support and deal with those in a decade. So a joke we've had in the Java platform group at Oracle, that it was funny 10 years ago, but is less funny now as it's becoming a reality, is our kids are going to have to support this someday. And sure enough, some of our developers, their kids are now, of the age where they're actually platform developers, right? So plan for that success. Make sure that the choices you're making and the vendors you're working with are the best for helping you in the long term.
Great. Thank you, Donald, for an amazing discussion. And thanks everyone for joining us today for this fantastic webinar. Thank you again, and please enjoy the rest of your day.